Hey guys, Mr. B here again, bringing you another math video. This video I'm just going to talk really quickly about limits at infinity for rational functions. So first thing you should know that a limit at infinity basically means what happens to y when x gets really big. So it's a fancy way of finding our horizontal asymptotes. So I always tell my students, ask yourself this question: as x gets big or small, so really, really big or really, really small, what happens to y? So what happens to y? So, for rational functions, you can go through the process, and the procedure is dividing by the highest power in the denominator. That's what I always use. So let's say we have a limit, and we want to look at it as it goes to infinity. And let's just start with a quadratic over a quadratic. So I have x plus 4 all over 3x squared minus 2x plus 1. So I have a quadratic over a quadratic. So the procedure is, what you would do is you divide everything by the highest power in the denominator. So if I look at the highest power in the denominator, I would have, I divide by x squared, divide by x squared, divide by x squared, divide by x squared, divide by x squared. So what ends up happening is these would cancel and make 1. That would cancel. I'd be left with 3. And x would cancel and the squared would cancel. And that's all that would cancel. So let me just rewrite what I got left here. Now I'm going to teach you a trick to this in a second, so just hang on. I never do this for this particular type. So, with this situation where you sort of cancel out everything except these two numbers. And, well, if I have infinity in these values, so if I think about 4 divided by something really, really, really big, it's essentially going to be 0. The same thing with these, right? These are all going to approach 0. So essentially what I end up with is 1 over 3. So where could you have gotten that from to start with? Well, you could have got it from your coefficients. Well, it was in front of your largest powers. So the rule is basically there's 3 rules for taking the limits at infinity of rational functions. You compare powers. So you look at comparing powers. So if you have, say, the first example is the same powers. So this example that we just had. So if I have, say for example, 5x cubed plus 2x plus 1 all over 10x cubed plus 10. I just don't want to write out a full cubic, but anyway, it doesn't matter. The highest power is the cube, and it's the same in the top and the bottom. So that all we do is we take the coefficients of them. So my limit as x approaches infinity of f of x for this particular function would just be 5 over 10, which is 1/2. So you look at the coefficients and you essentially just divide them. So the next scenario is highest power on the bottom. So if you have the highest power on the bottom, so you might have something like, let's see, 2x plus 1 all over 5x squared plus 10x plus 1. So if you have something like that where the highest power is on the bottom, essentially the bottom is growing much faster than the top. So this bottom is going to get bigger a lot quicker than this top. So essentially what that means is this guy is going to just get really close to 0. So the limit as x approaches infinity of f of x when the highest power is on the bottom is always going to be 0. Then the third scenario, I'll write it over here. So the third scenario is highest on top. So you might guess that if the highest is on top, so if you have something like 7x cubed plus 4x plus 1 all over 2x minus 1, then the top is going to get really, really big quicker than the bottom. So that means that this just going to keep growing and growing and growing. So in that particular case, the limit as x goes to infinity of f of x does not exist. So there is no horizontal asymptotes. Okay? So let me just recap that. So if you have the same powers, then you take the coefficients. If you have the highest power on the bottom, it's always 0. And then if you, yeah, it's always 0. If you have the highest power on top, then the limit is not going to exist as it goes to infinity. Let's just do a quick example of that. So let me just give you a function. So f of x is equal to 7 minus 5x minus 5x squared, all divided by 3x squared plus 2x minus 1. So if I look at this, I can tell immediately what the horizontal asymptote is, what the limit at infinity is. So if I look at it, all I got to do is look at the highest power. So the highest power is x in the top, x in the bottom, x squared, sorry. So that means that my limit, as x approaches infinity for f of x, is always going to be just, the coefficient of the x squared divided by the coefficient of the x squared on the bottom. So there it is, that's my limit. Nothing more, nothing less. You can immediately look at it and tell. So you don't have to worry about this method right here. Now, if you're really, really concerned about knowing this method, then you should look back at one of my other videos or check your class notes to make sure you know how to do it. But for rational functions, I tell my students, why would you ever use that when you can just look at it and tell? It's so silly that you need to do that. Now, you need to know that technique for other limits. Let me just throw another one at you. So let's go x squared minus 5x cubed plus x to the 4, all divided by 3x squared plus 10x to the 5 minus 1. So it doesn't matter. Again, it doesn't matter the order. It doesn't matter. Just looking for the highest power. So this one has a 4 in the top. That's definitely a 4. And then a 5 in the bottom. So the highest power is in the bottom. Therefore, the limit as x goes to infinity of f of x is 0. It's just always 0. Really, the only one you ever have to think about is this one right here, when you have the same powers in top and bottom. Then you have to do a little bit of math to get that. Every one of them is just highest in the bottom, 0. Highest in the top doesn't exist. Alright guys, so I hope this helps you in your quest to figure out calculus, and probably you're doing curve sketching or something right now. So thanks for watching, and I'll see you guys in class.